There you
Is it now unmute?
go. Yeah.
How come?
You can ask them.
Hello? Hello?
Yes, madam, we can hear
Can
you.
you-
Listen, it is not on. Yeah, now we can listen.
Okay, all this time I was on forcefully on mute. Now I'm okay. Thank you. Thank you. Thank you, Kiran. Good evening, sir.
Good evening, madam. Shall we start now, Dr. Patnaik?
Okay, we can wait 1 or 2 minutes, sir. Just
Fine.
yes, sir.
Good evening to everyone. Good evening.
Good evening, sir.
Good evening. Good evening, madam. Dr. Gadgil. Dr. Sahai, good evening.
Good evening, sir. Good evening.
Good evening.
Good evening, Dr. Sahai.
Yeah, good evening, madam.
So gradually people are joining, sir. 2 minutes we can wait.
Okay, we'll wait.
Why don't we start? Hello? Hello? Why don't we start?
Madam, we'll
We can
start.
start it.
More people.
Just 1 or 2 minutes people are coming.
And
So,
2 minutes
very
will be
fast they are
taken
joining.
15 minutes.
And we have 15 minutes buffer time is there.
Yeah, that's hardly proper, but anyway, 2 minutes from that will make a difference.
So now it is 2 minutes past, so 1 more minute. 6:03 will start. 6:364. Yeah.
Fine. You can start now, Dr. Patnaik.
Yeah. Yes. Okay. So good evening, good morning, and good afternoon for the final technical session of IWM-7. Now there are very important talks are there, 4 talks. Before that, we have also a distinguished scientist, Dr. M. Mohapatra sir, is there to kindly chair the session. So he, just to give you a brief introduction, Dr. M. Mohapatra is the Director General of Meteorology, India Department, and Permanent Representative of India with WMO, and member of Executive Council of WMO with a PhD in physics and 28 years of experience in meteorology. He has made significant contribution in involvement of early warning services of IMD. He brought laurels to the country from International Agency for Effective Cyclone Warning. He is popularly known as the Cyclone Man of India. He is the author of more than 105 research papers in peer-reviewed national and international journals. He edited 18 books, 7 journals. He received awards recognition from different agencies, including Fellow, Indian Meteorological Society, Certificate of Merit for Young Scientists by MOES, and 25th Biennial Monsoon Award. He is the president of IMS at present and chairman of Regional Soft Project Management Team of Severe Weather Forecast Program of South Asia, and was chairman of WMO Escape Panel on Tropical Cyclone during 2017-18. Technical Evaluation Committee for Consultancy of National Cyclone Risk Management Project, Mitigation Project. So over to you, sir, now. Thank you.
Namaskar, good evening, good morning to all of you. At the outset, I welcome all the distinguished speakers, delegates, ladies and gentlemen, for this special session during IWM-7. This special session is very important for each of us because it deals with socio-economic impact of monsoons mainly. We have the leaders in this field, starting with Professor Sulochana Gadgil and Rohinton Emmanuel, Professor UC Mohanty, and Nachiketa Acharya, dealing with various aspects of the socio-economic impact and related fields. So without taking much time, I would like to introduce our distinguished guest speakers, and I request the organizers to put up the slides for introduction. As all of us know, Professor Sulochana Gadgil is a known face in the field of monsoon meteorology, specifically, and in general meteorology to the whole world. She was trained at Harvard University with a PhD in applied mathematics, postdoctoral fellow at MIT. After 2 years as a CSIR pool officer at IITM, joined the Indian Institute of Science in 1973. She has made significant contributions to our understanding of the Indian monsoon and its variability, its links with atmospheric convection over tropical oceans, and the relationship of such convection with the sea surface temperature. She played a key role in the establishment and nurturing of the Center of Atmospheric Science, Atmospheric and Ocean Sciences at Indian Institute of Science, and spearheaded efforts to formulate the Indian Climate Research Program. She has served many committees in atmospheric sciences and is a recipient of several awards, including Lifetime Excellence Award in Earth Sciences of 2016 from Minister of Earth Sciences. One most important point I just want to mention here, she has been the brain behind the Monsoon Mission program of the Ministry of Earth Sciences, and she has spearheaded the various projects nationally and internationally for successive progress of the research and development in monsoon and its application to the society. Now I request Professor Sulochana Gadgil deliver our address.
Thank you. Can I have my PowerPoint, please? Can you show the PowerPoint, please?
Yes, madam, will show.
Yeah. Okay. First of all, I would like to thank Dr. Mohapatra for that very kind introduction, and also the organizers for inviting me to talk specifically on economic and societal impacts of the monsoon. The next slide shows the mean rainfall during the summer monsoon over India. And what you see is something all of you have seen before. This is the rainfall being high here and over the monsoon zone. What is of great interest is the variability of this average summer monsoon rainfall from year to year, which you see in the next slide. And next, now we have a very rich data set. This is going all the way from 1870 to 2021. And this is the rainfall anomaly of Indian summer monsoon rainfall, ISMR. Okay. And you can see that there is no climate change here, no change over the large scale, but certainly a very big decadal change. And this is very important, ISMR variability from year to year, because it has a very large impact on our food grains and GDP. Next. See, first of all, what is it? We would like to know what is the overall impact of the monsoon variability on food grain production and GDP of the country. What are our expectations? So offhand, we would think that deficit monsoon or drought will decrease the food grain production, FGP, and above normal or good monsoon or excess will lead to an increase in FGP. Soon after independence, contribution of agriculture to GDP was 50%, and by the end of the century, it has reduced to 23%. So it was expected that because of this and the overall development since independence, the economy would become quote unquote drought proof. The next slide will show you outline of my talk, where I will try and see to what extent these expectations are borne out by actual data. So I will talk about economic impact first, observed variation of FGP and GDP, monsoon rainfall and FGP, and major features of the impact of monsoon on FGP and GDP. I will not be able to discuss strategies for maintaining minimizing adverse impact or enhancing positive impact because of time limitation. I will also talk a little bit about social impact, taking famines as an example. Next, please. Now, what you see here is a very interesting graph generated by a Japanese scientist. And what it shows is from 1900 till almost this few years back, what has been the food grain production of India. And what you see is, this is the colonial era, where food grain production never increased. It's flat. As soon as we got independence, it started increasing, okay? Even before the Green Revolution, because of the development work undertaken by the independent government. And then with Green Revolution, it increased even more rapidly. So the next slide shows you what was involved in Green Revolution. Very quickly, Green Revolution gave rise to rapid increase in Indian food grain production over irrigated areas associated with rapid increase in yield due to adoption of new dwarf, high yielding and fertilizer responsive varieties of rice and wheat mainly. Remember that. It's primarily rice and wheat, and a substantial increase in fertilizer application and pesticide application. It led to a phenomenal increase in the FGP, which made it possible for the FGP to outstrip the fast population growth rate. However, now we are witnessing a fatigue of the Green Revolution. Next slide. And what you see here is the Indian food grain, which has increased remarkably. Note there is no change in scope with Green Revolution. How much ever credit science may take, actually the increase began soon after independence. But you see in the last few years, it has slowed down. The increase has slowed down, and this is not restricted to India. Even in world food grain, if you see, there has been a fatigue in the Green Revolution. So next slide. Okay, shows, in fact, another picture of the same thing from End of Poverty by Sachs. And what he shows is that this is the earlier colonial era, then we got independence, and then Green Revolution, which increased, but this is for GDP now. So this is his visualization of what happened to GDP of India. Next. Now, Indian GDP, if you look at it, then of course it is increasing exponentially, but the rate of growth earlier used to be what used to be referred to as Hindu rate of growth, 3.5%. It's only past the reforms in the 80s and 90s that we got higher growth rate of GDP. And you see here the change in slope. The next. Okay, now what is the relation to the monsoon? So what you see here is monsoon anomaly, ISMR, and food grain production. And what is very clear is very close correspondence between droughts or large deficit and dips in food grain production. So there is a very close correspondence between droughts and minima in FGP, and this is well known. Next. Okay. So largest impact of monsoon variability is on production of rain-fed cultivated crops. Now rain-fed cultivation is over 60% of our cultivated land. Okay, so it cannot be wished away. It is here to stay. And changes over rain-fed regions due to Green Revolution have been many. They have adopted new varieties and cropping patterns. In particular, changed over to monocropping over large tracts from what used to be a very complex cropping pattern. Now, this has led to major pests and diseases becoming endemic. So these are negative impacts of the changes that occurred in rain-fed farming due to Green Revolution. Next. Now, in fact, what you see is actually this is the yield of wheat that you see here. And you see very clearly the Green Revolution growth that took place, phenomenal growth during the Green Revolution. But this is a pulse tool, and the pulse yield has not increased at all. So pulse is a rain-fed crop, pigeon pea, and you can see that this has not increased at all. And what this means is that when with the impact of monsoon yields decrease, the impact is much higher because it's fluctuating around a very low yield. Next. Okay, so we did a quantitative assessment of the impact of Indian summer monsoon rainfall on food grain production and GDP. Okay, it is a surprise that no economist had done it, but we did it anyway. So this is published in the Economic and Political Weekly. My co-author is a mathematician and a statistician. So although it is complicated statistics, you can be reassured of its quality. Now, what did we analyze? We based, of course, ISMR data from IITM, food grain production from Ministry of Agriculture, and GDP at factor cost from Central Statistical Organization. Next, okay, what you see is our result. And this is where the surprise comes. This is impact on food grain production on the y-axis, and this is the ISMR anomaly, monsoon anomaly. And what you see immediately is that this is a very asymmetry in response. You see rapidly it decreases the food grain production, which means deficit in food grain production is increasing rapidly with increase in deficit of ISMR. But relatively speaking, if ISMR increases beyond the mean, it is a very, very slow increase in FGP. So this is an asymmetry. The same anomaly of ISMR, when negative has a very large impact, and when it is positive, it has a very small impact. Okay. Now, this means that even if monsoon stays constant as we expect it to, losses will never be made up by the gains here. So this is a very dangerous thing. Next. Now, in fact, what has happened is not only are we seeing asymmetry when we look at the entire data, when we split the data into before 80 and after 80, we find that after 80, the asymmetry has increased even more, with hardly any increase at all, with increase in monsoon rainfall beyond the mean, but impact being 2 to 5% irrespective of, this is the impact in GDP, but impact being very large in FGP when ISMR anomaly is negative. Okay, and I have no time to tell you why, but it is all in the paper. It is because of climate insensitive agriculture. The next. Okay, so why asymmetry and why more asymmetry since the 80s? So long answer I said is in the paper, but I will give you a summary. Okay, see, deficit rainfall always leads to yield. Why does above normal rainfall not lead to good yields? Harmful impact of the green revolution. This is because now cropping patterns have changed to monocropping over large tracts, and pests and diseases have become endemic. Also, intense farming led to loss of fertility in farms. In this situation, even if the rainfall is good, yields will not be good unless fertilizers and pesticides are applied. You see, this is a new element that has come because of modern technology. And farmers do not apply them in rain-fed situations. In irrigated thing, they would, because they are not sure that the benefit outweighs the cost. Okay, that it's cost effective. So next. Okay. Now, in fact, if we look at GDP also, then you see the same thing, that negative ISMR has a huge impact and positive has a relatively less impact. And what is more is that GDP impact of deficits or droughts has remained between 2 to 5% throughout, okay, right from 1950 till now. So next slide says that despite the sharp decrease in the contribution of agriculture to GDP, it is seen that the typical impact of severe droughts on GDP has remained between 2 to 5% throughout the period. So question of drought-proof economy does not arise irrespective of what you spend on development. One has to think of better ways, more climate-sensitive ways of taking care of this. Now, this is because although agriculture does not contribute as much to GDP anymore, because 60% of the population is still part of the agricultural workforce. So the impact of drought on the purchasing power of the majority still leads to a very large impact on GDP. This is the reason. Next. Okay. Now I come to only one example of societal impact. Okay. And that example is that of famines. Okay. And I say that because I would like to end on a somewhat positive note, because this is a successful story of mitigation of social impacts. Okay. Now, most of meteorologists believe that the major cause of famines is the food shortage due to droughts. Okay. And so a famine is considered to be the most adverse impact of monsoon variability. I think people will agree with this. This is what I also thought before I started reading up the literature. Now, to understand the relationship of famines to droughts, let us consider what our Indian experience is in famines. The impact of droughts prior to and early in the colonial era was minimized by traditional social institutions and collective use of farm revenues. Okay, this made a big difference. So they were not famines to the extent that they were afterwards. But you see, the policy of the British is to maximize the revenues. So they did not bother about all these social institutions. In fact, they were systematically killed of collective use of farm revenues. All the revenues had to go to the British. So the major famine of 1876, 78, 96, 97, 99, 1900, in which millions died in the colonial era, were associated with droughts. Okay, so it is true that when not managed properly, droughts will lead to famine. However, after independence in 47, despite severe crop failures in association with droughts of many, and I don't have to mention, we all remember them, 72, 79, 87, and so on, there were no famines. This is a point to note. Next. Okay, the last famine, one of the largest, was the Bengal famine of 1943, in which 2 to 3 million people died. This occurred when the monsoon rainfall over Bengal as well as ISMR was above the average. Okay, this I looked up the data. Fortunately, thanks to IMD, all data are available very readily, and hence could not be attributed to a drought. So even when we had good rain, we had the worst famine, with so many people died. Now, why is this? So the Nobel laureate Amartya Sen attributes the total absence of famines in India since independence to the installation of multi-party democratic system. The contrasting case is China, which has been more successful than India in economic progress, which had the largest recorded famine in history during 58 to 61, in which 30 million perished. You see, in a democratic system, no government can get away with people starving on a large scale. Immediately, media make a big fuss, and immediately some measures have to be taken to avoid starvation. See, this kind of feedback is not there in systems like China, and this demonstrates the role of social institutions and governance in mitigating the social impact of the monsoon. I will stop here. I would like questions if there are any. Thank you.
Thank you, Professor Gadgil. Now, floor is open for the questions and comments. So if there is no comments, I would like to. Okay, I don't find any hands. Okay, so thank you very much, Professor Gadgil, for bringing out the various socioeconomic impacts of Indian summer monsoon on food grain productions and GDP. He also clearly brought out how the systemic change prior to independence and after independence helped to mitigate the adverse impacts of the monsoon. It has also clearly brought out how the role of societal systems and democracy play a dominant role in mitigating the disasters like droughts and floods in a particular society. So while we consider the reliance and self-reliance, certainly we were much reliant upon others during the pre-independence era, and gradually we moved towards complete self-reliance. And as far as Southwest monsoon and its monitoring, predictions, and early warning is concerned, we've also come up a long way. I just want to have your opinion about what should be the future course of action so that we can further mitigate the adverse impacts of the monsoon on the society, and you can optimize the information on monsoon for socio-economic progress in the country. Professor Gadgil, madam.
Oh, that is a very interesting question, but will require another lecture. Okay. In fact, we have been working on farming strategies which can minimize, the risks involved with deficit rain and enhance the profit due to good rain. But as I said, it will require another lecture. What is required is interdisciplinary research, which involves also agricultural scientists, crop models, not just us, not just atmospheric scientists, and more important, farmers. Because, it is the farmer who has to deal with the whole system. We can look only at the atmosphere and rainfall and pat ourselves on the back when the forecasts are right. But the farmer has to manage the whole thing so that finally he makes profit. You see? So he is aware of the economic constraint. He is aware of the soil fertility constraint. He is aware of the hydrological constraint. And he is the one who raises the right scientific issue. This is my experience. So it is genuinely challenging scientific problem which requires interdisciplinary effort. And that's what I've been doing for past several years by collaborating with farmers from a semi-arid region, Paugada, who farm groundnut. So there is an enormous scope for us to do better in agriculture of rain-fed systems, given the kind of phenomenal progress we have made in prediction, but also because of the enormous data we have on climate variability. Remember, variability gives probability, which is the zeroth order forecast. And the first order is what you people give. So with those, the opportunities are enormous. But we need to work together with agricultural scientists and more importantly, farmers, so that we don't give recommendations that we think are proper, but which are actually useful to the farmer. Thank you.
Thank you very much, madam. We are really privileged to listen from you about the progress made with respect to the science of monsoon and its impact on Indian agriculture and Indian food productions. So thank you very much. May I now request Professor Emmanuel to deliver the talk on new technologies and tools. Professor Emmanuel is Professor of Sustainable Design and Construction and Director, Research Center for Built Environment Asset Management, BEAM, at Glasgow Caledonian University. He has long worked on urban heat island studies in warm regions and has taught and consulted on climate and environment sensitive design, building, urban sustainability and its assessment, building energy efficiency, thermal comfort, and carbon in the built environment. Rohinton was the secretary of the largest group of urban climate researchers, the International Association for Urban Climate, and was a member of the expert team on urban and building climatology of the World Meteorological Organizations, as well as the CIB working group on buildings and climate change. He is currently the coordinator of Erasmus Mundus Joint Master's Degree Program on Urban Climate and Sustainability. So on behalf of all of us, I request Professor Rohinton Emmanuel to deliver the talk. Your audio is muted.
Okay, yeah, I hope you can hear me now. Yeah.
Yeah, now it is fine. Yeah.
Okay. Sorry. My apologies. Let me put the screen. Okay. Thank you, Mr. Chairman, for the kind words. It's my turn to now present something more esoteric. I think in the previous talk, Professor Gadgil presented some life and death issues about food security and so forth. But mine is more on the well-being side of things. Although it may not be as life-threatening, but it could also be in the coming months could be very much so. Right? So I want to present about the overheating problem in the urban areas of South Asia, and with special reference to Sri Lanka, and what mitigation options are there, and how the window is rapidly closing for us to be able to use this. So my line of reasoning is to present something about the global increasing overheating, and then fairly quickly come up to the human consequences of overheating in South Asia, and then present some recent overheating evidence from in Sri Lanka, and some of our simulation works to see how this could be what countermeasures are there, and to reduce the overheating. But to show also that the window is the window of ability to mitigate is fairly rapidly closing, and therefore some words on how we may proceed in the coming years. So global overheating, you might have seen, of course, the AR6 was very emphatic. It said human exposure to global overheating is increasing everywhere. Partly this is due to urban population growth. As we know, more and more of us are now living in cities, so therefore you would expect more people to be exposed. So that is partly the reason. So it is not meteorological, but partly it is also urban warming, especially the urban heat island effect. This paper you might have seen recently, it came out last year. It was trying to estimate how much of this overheating exposure is due to population growth and how much is urban warming. And in here they are defining extreme heat in an index, a human comfort index called WBGT, wet bulb globe thermometer index. Anything over 30 is considered fairly dangerous in WBGT. That comes from a US standard, and I'll show something later. For South Asia is slightly different, but just to keep this in mind, so that's the definition of extreme heat in the last 30 odd years. On the A panel on the left side is the total increase in human exposure to overheating. It's about 2.1 billion person days per year. Of which about 2/3 comes from population increase. And that kind of makes sense because global urban population is rapidly increasing. Now we are a majority urban dweller planet. But a third of it, 0.7 billion, comes from the urban warming. So this then is also a key part of our the evidence globally. When you look at South Asia, much of it is urban warming, partly because the urban population growth is starting from a very low base, even in very urbanized parts of South Asia, including in Sri Lanka. The urban growth is relative, or the urban share is still relatively smaller. So it is likely that we will have a bigger effect due to the urban warming. And that's seen here in this panel. And you could see that the sort of pink color indicates what share of increase is urban warming versus the green is more population warming. And you could see in South Asia in general, it is sort of dominated by pink, meaning that we have more of our warming coming from urbanization rather than in other regions. So this is something to also keep in mind. This is, of course, only for extreme heat. And A little while earlier, you might have seen this paper for the MIT researchers were looking at anthropogenic climate change and the particular challenges that we in South Asia face. This is in a slightly different index. Here we are looking at the wet bulb temperature, the maximum wet bulb temperature as the measure of the hazard, the heat hazard. As you know, at a certain maximum wet bulb temperature, beyond which it will not be possible for human beings to live. That is usually thought as 35 degrees, at which point the human body cannot lose heat anymore, even in shade. So that's the sort of extreme end of the extreme heat, as it were. This is a little earlier study, 2017 paper by Im et al. And on the left side is the historic climate data, but plotted in wet bulb temperature for the last 30 years. So historic. In the middle is the RCP 4.5, so the so-called Paris Agreement emission scenario, keeping the world's temperature, average temperature increase to 2 degrees or less. Even that is beginning to have a lot of red areas in parts of northern and eastern India and also northern Sri Lanka, definitely in Pakistan and most of Bangladesh and so forth. But if you look at the right side, the RCP 8.5, which is the business as usual emission scenario, the picture is very clear that many parts of our subcontinent would become basically uninhabitable, at least in the outdoor. So activities that require working in the outdoor, in construction, in agriculture, in all of those kinds of fields, this becomes extremely dangerous, or it could become extremely dangerous in large parts of the subcontinent. It's something then to keep in mind. So it is in this context that we want to look at the thermal discomfort and the extreme heat situation in Sri Lanka. This is a conference on monsoonal climates. So what is the recent trends in a very hot, humid monsoonal climate? Sri Lanka, of course, is the tropical, the sort of exemplar of a warm, humid climate. It's almost on the equator. And what effects the recent changes or what effect the urban planning decision making could have on these recent changes on mitigation of the climate. So we take the last 30 years or so of data. Unfortunately, not all stations had all 30 years. So it's 96 to 2020 from all these weather stations. Most of them are urban stations. So we managed to have 20 stations. And we're going to plot it on a thermal comfort index, not so much on a extreme heat index, but in the universal thermal comfort index called UTCI, and also physiological equivalent temperature. I'll say something about it in a minute. So according to literature, the very hot or extreme hot sweltering conditions in UTCI would be over 46. I wouldn't bore you with how it is calculated. It's a measure of thermal comfort. So it takes into account the radiation, the temperature, humidity, wind, everything together. What people are wearing, what activities people are doing, all of that together. And in PET, physiological equivalent temperatures, the same sensation or same danger would be at 41. So just to keep that in mind, the UTCI here is extreme would be 46, very strong would be 38 to 46 in the UTCI. And here is how the UTCI urban universal thermal comfort index looks in the last 25 years or so. We have longer data, but I'm just showing the last 25 years of data. And those of you who know the geography would know that in the middle of the country is a very high mountains, 2,500 meters and above. So that's the only reason why there are some green patches in the central hills, because it is very high. Leaving that aside, even in 1996, the very strong heat stress was quite rarely present, except in the northeastern part of the country. But by 2020, it is very clear, a very large area of the country is now in very strong heat stress. And that the dangerous thing, of course, is this is just this is only the presence of the hazard. But if you look at the exposure, where more people are, much of these districts are rural, so they are not so very strongly affected by, I mean, exposed. But even in the Colombo metro region, you can see a very strong heat stress is now beginning to emerge in Sri Lanka. That was in the hottest month, April. Here is the coolest month, January, during the northeast monsoon time. The situation here too is also very critically reaching those levels. So on the southwestern side, because this is northeast monsoon time, so on the southwestern side of the country, including in Colombo metro region, the moderate heat stress is beginning to appear. This is in the coolest month. So in a tropical climate where annual variation is hardly anything, and this is therefore beginning to be a problematic situation. So a problem climate is being made worse by the urbanization as well as the global warming parts of it. So very strong heat stress leading to almost extreme heat stress, which hardly existed just 30 years ago, is now very common. But also, even in the coolest month, this is beginning to be moderate heat stress to the higher ones. That including in very most densely populated parts of the country. What can be done? So we are looking at the literature, what can be done, and look at what effect a green infrastructure-based planning or more shading-oriented planning, as they did in traditional Indian and Middle Eastern architecture. So what effect these approaches to overheating mitigation could have on this rapidly changing situation in the country. So we looked at the street orientation, the height of buildings, the presence of greenery, etc. And SVF is the sky view factor, how much of the sky is seen in an urban setting. The more the sky is blocked, of course, that means there are more shading. So all of this we are looking at and to simulate and to see what effect this could have on the overheating mitigation. Here is the situation in the last 25 years, and that in terms of thermal comfort, the red dotted line is the limit of very strong heat stress. The blue dots are the base case as it is. EW means east-west street, a street that is running along the sun path. With very little shading and very little greenery, it would have been, and it always will be in the very strong heat stress. But if we had properly managed it, increased the shading, planted a lot of trees, etc., although the R square is not so high, there is a slight trend that we could have reduced this extreme heat stress to very strong or moderate heat stress. So we couldn't have eliminated it, but we could have helped to manage it. But as you can see, the trend, although is very not so strong, it is approaching the very strong heat stress limits. So our ability to do something to improve the situation, mitigate the overheating, while it is possible, but it is also getting reaching the thresholds of impossibility. So what approaches then could work? We would need higher shading, vegetation related urban planning. This is not part of the urban planning approach to climate change management. Climate change management in the countries largely still talks about emission control, etc., but not about the human exposure to the overheating and what we can do in terms of our cities, because more and more people are now beginning to live in cities. So high shading, vegetation related heat stress management need to be part of our guidelines and so forth. But even this would increasingly be difficult to achieve as the warming continues. Unfortunately, the message is that if this keeps continuing, more and more people would turn to air conditioning, which of course then is a vicious cycle, because that all what the air conditioner does is take the heat from inside the building and throw it outside, where outside is already approaching unlivability. So that wouldn't be an increasingly interesting option. So as such, we certainly need policies that reduce global warming and working with the regional countries to reduce the regional warming, which would be very important. But at the same time, we also need to do this local action, which enables people to tolerate, at least partially adapt to the approaching urban heating, large scale stuff. So this needs to be prioritized in terms of climate change adaptation action. As I said, that's still not the case. So this the role of urban planning needs to be also presented there. This is, I think, one of the calls to the meteorological community to these climate services to be targeted at the planning community as well. We need this sustainability intelligence. We have done a lot of this kind of this is all unintended consequence. So with there's a need for an intelligent way to approach this sustainability. Ultimately, I think this has to be linked to socio-cultural sides, because the adaptation to overheating is not entirely technical. It's not a question of planting trees and shading and air conditioning. It's also cultural. It's also behavioral. So all of that needs to be also done. We need to also think of broadly system thinking, what effects climate change mitigation would have on our quality of life related approaches. So that too needs to be thought about. A lot of countries and a lot of societies areas already have the knowledge because they have lived with extreme heat. This is not new to humanity. So there is a need for this co-production of knowledge. We are working with different stakeholders and to co-design the responses so that we don't create some other unintended consequences as in the process of trying to manage the heat. Thank you very much, and thank you once again for the opportunity to deliver this talk, and I'll be happy to answer any questions you might have. Thank you.
Thank you very much, Professor Emmanuel. It was an excellent talk about the urban heating and mitigating approaches. Any comments and questions? I don't find any hands, but however, it was a very interesting study taking Sri Lanka as an example. And of course, for South Asia, it is a real problem as long as urbanization and urban heating is concerned. And your suggestions will go a long way in policy and planning. So thank you very much.
Thank you. Thank you.
May I request you, our next distinguished speaker, Professor UC Mohanty, and I request the organizer to put off the slides for introductions. Professor Mohapatra Mohanty specializes in numerical weather predictions modeling in tropics, with special emphasis on extreme weather systems over India. After superannuation from Indian Institute of Technology, Delhi, currently he's serving as a visiting professor in School of Earth, Ocean and Climate Sciences in IIT Bhubaneswar. He has developed, adapted, and utilized short, medium, and extended range prediction systems with mesoscale, regional, global, as well as multimodal ensemble models in academic research environment and transferred for operational use. Professor Mohanty spearheaded the efforts to implement severe thunderstorm observations and regional modeling storm program in South Asia. And he is a known figure internationally with respect to various field experiments, data assimilations, and especially the mesoscale modeling. For his pioneering contribution to Asian summer monsoon studies and NWP in tropics, he received several awards, including prestigious Shanti Swarup Nagar Prize, Sir Gilbert Walker Gold Medal. He has published more than 300 scientific papers in peer-reviewed journals, supervised 43 PhDs, and several MTech and MSc dissertations. For his overall contributions in atmosphere science, he has been elected as Fellow of the 4 National Academies of Sciences and Engineering in India. So it is a privilege for all of us to welcome Professor Mohanty to deliver the talk. Over to you, sir.
Thank you very much. My presentation visible?
Yes, sir, fine. You can proceed.
Thank you very much, Dr. Mohapatra, for a excellent introduction. At the outset, I thank the IWM-7 Scientific Committee for inviting me to give a talk on this soil moisture and its impact on monsoon. And I have with me my young colleagues, Ara, Manas, and Palas, who have contributed to this talk. So in my talk, actually, I will give a brief background of this talk, but I will cover mainly three aspects. I will show what is the impact of the land, what is the importance of land surface processes. Then I will show its need, and then I will present on a data set that is prepared for 37 years. Very high resolution data set on land surface, soil moisture and soil temperature and its validation. And at the end, I will show impact of high resolution land surface initialization, both on very short range thunderstorm, monsoonal thunderstorm, and monsoon depression to that of this seasonal scale prediction. So if we see that the Earth's surface exchange momentum, heat, moisture, and gases with the atmosphere and thereby influence the climate systems. The important land atmosphere coupling pathways are three major pathways. One is the water cycle, that is the changes in the evapotranspiration and its variability influences the precipitation. Other aspect, the energy cycle, that partitioning of surface energy like sensitive heat, latent heat, mainly. That land surface plays a very important role in partitioning that, and as a result, it is dominated the boundary layer process, because if sensitivity is high, then boundary layer is larger or more deeper than the latent heat and vice versa, and ultimately that leads to the formation of cloud and hence rainfall. And third aspect is the biogeochemical cycle, that is carbon and nitrogen cycles. That is also very much controlled by the land surface, land area, land cover, and land surface processes. So soil moisture is a key variable that controls partitioning of surface turbulent fluxes, that is between the, as I told, the latent heat and sensible heat fluxes, and which have very different role in the governing the convective activities and precipitation and so on. Understanding and representing the surface heterogeneity are important, as they favor initiation of convection and have potential development of severe weather events such as monsoonal rainfall and thunderstorm and so on. Indian region lacks land surface observations because we have only few observation network in the country, but need a understanding and representing the land surface processes, and the realistic coupling between land surface and atmosphere is important for prediction of various convective processes. So the scope of the study, as I have already told you, that I will go first to see show you the need of land surface process, sensitivity of land surface processes, and simulation of monsoonal rainfall events. For this purpose, we have used a high resolution measures like WRFM model. So I will not go to details of the model configuration. So we have picked up 4 cases to demonstrate the need of the land surface processes. In that, case 1 and case 3, they involve the month of the June, and where actually the monsoon is in progress, and the central India and the northwest India having no rain. That means it is just a source of heating and development of the heat wave conditions in the northwest India. And the other 2 cases are a case of August, where actually whole country is covered with the monsoon, and the land is almost saturated with the rainfall and with cultivation and farming and so on. So therefore, these two contrasting period of monsoon. One is June, middle June, and one is the middle. Other two is the middle August. And for this purpose, we have used two schemes. One is the NOAA scheme, and other is the thermal diffusion scheme, where actually we kept the soil moisture as constant. In the NOAA, it is interacting. So then you see the verification of model simulated 2-meter temperature and 2-meter specific humidity. Then you can see that in the case of the case 1, actually, which is the again month of June, and then you can see that a very good correlation between the heat 2-meter temperature and that observed versus simulation, and then the case 2, that is the NOAA, and that is the August case. And this is the set of observations with which we have compared with the central India, where only few observations there. The NOAA shows a better agreement with the observations, and the inference is more visible in the case of 1, that's in the case of June, where you can see they are highly correlated and all is following the same line and with biases 0.74 and 77 for the temperature and so also humidity. And in the case of August, we have little dispersion because at that time there is not much difference between the both schemes, because that time already land is highly saturated. Then this is show that case 1 and case 2, the diurnal variation of evolution of surface field over the central India, and this is the temperature and moisture and latent heat and central heat and latent heat fluxes. And again, I am showing for the variability only case 1 and case 2. And here also you can see that the same thing occurs, that in the case of case 2, there is not much change in both these schemes that we are using, fixing the soil moisture or getting the interactive soil moisture in the process of NOAA. And so there is not much difference between both in the central heat and latent heat fluxes. And also, but whereas we can see that in the case of June, with the TD scheme, we have more central heat and more latent heat and less central heat fluxes. And then if we see the precipitation, this is the observed IMD precipitation for day 1, day 2, day 3, and this is the NOAA scheme. This is the thermal diffusion scheme, and where this is the difference between NOAA and thermal diffusion. Then if we see that the thermal diffusion scheme gives more precipitation, and particularly over the North Soviet India and Central India. And this is all 4 cases. Case 1 and case 3 is for the June, and case 1 and case 2 and case 4 for the August. So if you see that the NOAA simulated rainfall is better, agreement with that of the IMD analysis, that is 0.25 graded analysis, and whereas this TD is giving the overestimated values, then this shows the mass static energy and crash static energy and latent heat fluxes. The energy is integrated from the surface to that of the 300 HPA, and here you can see that this is the energy difference between NOAA and the TD scheme, and you can see that both in the case of 1 and 3, that is June month, where the central India and the northwest India is not having the monsoon appear there, then we have a large with differences, and which is substantially reduced when land is saturated everywhere. Then we have started the surface feedback. So for this purpose, we calculate the term of moisture efficiency, vapor transmission, and precipitation efficiencies, and then the precipitation, that delta P, that depend upon the efficiency effects the surface effects, remote effects, and residual. These 4 components that contribute the efficiency of the estimation of the precipitation from that evapotranspiration. So when we estimate that for the only 4 cases, that is June, case 1 and case 3, and case 2, case 4 for the August, then you can see that this surface effect is quite dominant and is more dominant in the case of the when monsoon is in the progress, that is the onset phase and progress of monsoon, and it is still prominent, and but less than that of the June, and when actually land is well saturated for the entire country. So this clearly demonstrated the surface process feedback on the precipitation mechanism that occurs during the monsoon process. Then with this study, then we have started the development of high resolution graded surface data over the Indian region. And as I told you, in India, we have only few places having soil moisture and soil temperature and radiation observations. Then we want to see as uncoupled LDAS system, how we can use these parameters and prepare the land surface variable soil moisture and soil temperature at different depths at 4 by 4 kilometer resolution. And for this, the LDAS flowchart is very well known to all of you, so I will not take much time. The forcing at the surface fields like 2 meters temperature and moisture, and 10 meters wind and pressure, rainfall and long wave and short wave for surface energy balance. And then it needs surface parameter characteristics, land use, land soil, textures, and vegetations. So land use, land cover, and vegetation was taken from the NRSA Bhuvan, and whereas the other properties of land surface that is not available readily for the Indian region, so it was taken from the lookup table from the global data. And then after land surface data is generated, it can use for the verification as well as for the couple it with the WRB system, and can be done model forecast. So experimental design that we have taken actually different type of data that is available, that is MIRA and MIRA2 and CFSR and ERA entering and GL-DAS data that are all available. And we have the AWS stations observations over the India that is given in the figure here. And we selected the 4 regions, north, south, east, and west, that is given in these figures. And these are the observation points. And then we have done numerical integration are also conducted using the reanalysis data sets at 4 kilometer spatial resolution for the period 2009 to 2013 first. And then this is the validation of LDAS input. That is what I told you, that as you can see, that the better match is there. It is NCEP CFSR, climate forecast system reanalysis, and also GL-DAS compared to ERA and MIRA data. So, and this is the error statistics that also signifies the same thing, that the NCEP CFSR 2 meter temperature and surface pressure and 2 meter humidity are better correlated or better matched with the observations, and short wave radiation, long wave radiation is that of the GL-DAS, a better agreement with that of the observations. Therefore, for the analysis, we have taken these 2 data sets and then we have carried out 5 numerical experiments to decide what type of combination is better. So experiment 1 is the CFSR, surface data and GL-DAS radiation. Experiment 2, CFSR, hourly data, both radiation as well as surface data. Experiment 3, the ERA interim data of surface fields and radiation from GL-DAS, then MIRA, then surface field hourly data and radiation field from GL-DAS, and MIRA interchanging from MIRA products. So these 5 experiments are carried out, that what type of combination gives the better results that agree with that of the observations and validations. So here actually this is the plot of these all 5 experiments and that of the GL-DAS data, and below is the Taylor's diagram for the root musical errors, standard deviation, and correlation. And this clearly shows that in the experiment 1, which use CFS as surface field and GL dash radiation budgets at the surface, that gives a better than other methods. Hence, those are things are used for the analysis of the surface fields at high resolution. And to compare that thing, we have used actually observation tower from IIT Kharagpur soil moisture data, and you can see that Kharagpur data is the tower data and the TRMM, the precipitation with that of the soil moisture that is observed, and versus that of LDAS for the period of 2013. Then you can see that the soil moisture is a little overestimated, but almost they are in good agreement with that of the observations. And then we have seen that the whole country that the AWS data that is available observed versus LDAS data. And then you can see that north, south, east, west, all the sectors we have seen. So this shows that the soil moisture analysis is a little overestimated than that of the observed. And this is the temperature field, T2 soil temperature, again from those places. Then this is the soil moisture distribution we have taken for the above normal year 2007 and deficit year 2009 and normal year 2010. There also it is quite agreed with that of the situation with the satellite, GL dash and LDAS. So LDAS shows that in above above normal years, we have the more soil moisture, and the deficient years that is this and so on. So also the temperature just reverse, it is more temperature in the deficient years, soil temperature, and less in the normal excess years. And this is also above normal. And then we have taken the 25 0.25 degree rainfall data of IMD, and instead of that of the stream data, and then we carried out this analysis of 3-hourly data of 4 by 4 kilometers over the entire country for the entire period of 1981 to 2017. And then we have make the composites and want to see that what happens in deficit years and what happens in excess years, 9 deficit years. And there also it clearly shows that soil moisture, except northwest India, it is deficient, and also soil temperatures less there, and particularly we see that deficient monsoon rainfalls have cool and wet spring, and that reflected in the rainfall in the subsequent monsoon period. Similarly, there are only 3 excess years are there in this period. That is that also shows the similar type of concern, that is in the excess monsoon have a warm and dry spring land conditions. Then we have seen the seasonal and the annual soil mass and soil temperature trend, and with a rainfall with a 30 years trend for that 37 years data. That also shows the same contrast. Spring soil temperature trend is likely to link with the June, July, August, September rainfall trends. So that's why it is consistent. And then we want to see the humidity and wind at 850 millibars, specific humidity and wind. We saw that actually, as I show you that the northwest India, there actually soil moisture started increasing. It is mainly due to that actually the convergence and more soil moisture in that region, and that is more in the month of June, and it is quite less in the August, where we have the really that is a period of climatological weaker monsoon, and then September, where again it is amplified, and in general it shows that whatever is consistent with the soil moisture and soil temperature with that of this trend.
Sir, you may conclude.
Then we have seen the temporal correlation between GL dash and L dash with that of the observations at 4 kilometers. So I'll quickly skip this thing, and I'll go to the impact of soil moisture installations, intense convective activities. That is my third part. And the thunderstorm simulation during monsoon 12 July and 14 August, you can see that when is the control, it is showing the overestimation. But when we have the soil moisture, we have taken from NOAA and our LDAS, they are quite agree with that of the what is observed in both the cases. Similarly, we have taken about 8 monsoon depression cases and spread over the different years. And integration was done 3 to 4 days in advance. And there also,
you may conclude, sir.
Okay,
sir.
So I will go quickly this thing. And this shows that actually we have quite large improvement takes place in the track and the track of the about 20% improvement in the track that we can see if we take the soil moisture, soil temperature that we analyze and take the scheme like NOAA. So we have done also signal run, and as time is not there, I'm skipping that thing, but I'll come to the conclusion. So here is some 4 by 4 kilometer 3 hourly soil moisture, soil data are generated for the Indian region for the 37 years. Now it is extended to 40 years. And the generated high resolution soil moisture and soil temperature products have good agreement with AWS stations observations. The spring soil moisture and soil temperature is likely to link with that of the monsoon precipitation during June, July, August Indian monsoon rainfalls. LDAS soil moisture and soil temperature has improved the simulation of mesoconvective activities and precipitation, and also the track of the monsoon depressions have improved 10 to 20% with use of the LDAS soil moisture and soil temperatures, and with that of the depressions and soil moisture initialization in the CPC has a better scale in simulating Indian summer monsoon rainfall. Thank you very much.
Thank you very much, sir, for your excellent talk. It is a new intervention in the entropy in Indian scenario, and it has demonstrated with your work that there is enough scope to improve the forecast in terms of accuracy, in terms of the delivery to the various requirements, including the agriculture and disaster management. Because of the shortage of time, sir, we requested you to minimize. Otherwise, sir, it will be very useful to all the youngsters and researchers in this field. Any questions or comments? I don't find any hands raised. So, Sai, once again, thank you, sir, for your excellent talk. And we'll be moving towards the next talk.
Thank you very much for giving me the opportunity.
Yeah, the last talk of this session is on the new technologies and tools. I request Dr. Nachiketa Acharya to deliver the talk. Dr. Nachiketa Acharya is a statistical climatologist and young and energetic, and he has contributed a lot towards the development in the field. He is associated with the Department of Meteorology and Atmospheric Sciences, Pennsylvania State University, as an assistant research professor. He has also held influential positions at International Research Institute for Climate and Society at Columbia University. And he has made significant contribution towards the understanding, monitoring, and prediction of short to medium range while working in National Center for Medium Range Weather Forecasting. He has also been associated with the University of Delhi and Bhubaneswar. He received his PhD in statistics from Utkal University, and he is actively engaged in several regional climate outlook forum and co-leading the building block 3 of regional information for society under WCRP. Now I request Dr. Nachiketa to proceed for his talk.
I just want to share my screen. Please let me know when you can see in a presenter mode. Is it visible? presentation mode?
It is fine. You can go ahead. It is fine.
Okay. Okay, thank you, organizer, for giving me this such a big opportunity to present my current and ongoing work. So today, I'm going to discuss about some ongoing work on probabilistic multimodal ensemble using machine learning. The motivation is very clear. Like we saw the yesterday's talk by Dr. Pai, that IMD was working on this whole MME system in a couple of years, and from last year they are using MME in a operational mode. So although it is established, but we need a lots of research to improve the skill. On that note, I want to say like that's my motivation. The highlights of the talks, I can pictorially present that we know there's lots of dynamical models, especially with the all couple models. So how to use the inputs of all couple models and doing a kind of explainable machine learning methods and prepare some probabilistic focus, because seasonal focus for Indian monsoon should be in probabilistic way because there's lots of uncertainty within the system. So with that, a little bit of example, like why we need multiple models. I just took one example in 2009, which was a very interesting monsoon. So before, like, let's say we're in May 2009, and we have lots of output from the climate models. And looking at those outputs is very not sure like which model are actually depicting the real fact, which is going to be after 4 months. And after the October, when we have the output from the observation, and we see that the pictures, which is not same as all the models. So here is the one example in practical way when you go for the real-time prediction, like how to believe in one model. So that's what we really need a multi-model. Now come to the probabilistic multi-model. I want to share that what are the work already has been done for multi-model ensemble. So, you know, people are going for the simple equal weight to different weight based on their prior, performance and combination with different linear regression. But most of the work is actually concentrated on the deterministic forecast. I just want to mention one pioneer work by Dr. Krishnamurthy in 1999, who come with the idea called super ensemble. After 1999, like up to now, there's like lots of work on the deterministic forecast in the MME, but there's very few work on probabilistic forecast on MME, especially in Indian monsoon. So just to explain like what is the probabilistic multimodal in a traditional way, I want to make sure that the audience understand what we're going to present. So basically, first we need to calculate the probability from each GCMs. And there's a two-way, one is non-parametric and one is parametric. Instead of going the equation, I just want to give an example, like suppose one model has so many members, and members depends on the initial conditions, boundary conditions. So at the end of the day, we have lots of output from a single particular GCMs. And then we can simply calculate like how many members falling in each categories, and those categories comes from the climatological percentiles, and we can calculate a probability. Another way, we can assume some parametric distribution. Most of the cases we go for the normal distribution, and then we can use a linear model for the potential predictability comes from the model's members. For example, you just take the ensemble mean of model members, and you then convert this whole linear forecast to a normal distribution setup and get a probability. So that's the way like probability comes from the models. Now we're talking about probabilistic multimodal. Let's see in a non-parametrics case, suppose we have the probability for each model. Now the question is how we give the different weights. And the weights comes in different approaches. Very common approaches like giving the equal weight, which is average of probability, or giving the weights based on the members. Like if one model has lots of members, give them more weights. But traditionally it's not working because it is not assumed that more members mean more skill. So we have play with different approaches and we publish papers on that. But there's a huge limitation on this counting method because it's not very straightforward. Like counting is working when you have like few members, especially on the S2S scale where you have only 7 or 8 members. So it's always like overestimate of probability. Now coming to the parametric approach, as I already explained, like parametric approach based on linear model assumption and the normal distribution. But there is a huge challenges how to calculate the spread of the distribution. And these are also lots of different way. We also play with different way and found some correlation-based technique is actually works. But there is again a huge limitation on the parametric. The huge limitation is, first, we have to do for a two-stage modeling. First, two-stage mean first you have to develop a deterministic MME, then you have to convert in a probability. And there is a huge assumption of normal distribution, which may work but may not, especially in different like spatial scale of Indian land, like not everywhere the rainfall following the normal distribution. So on that note, we are thinking, what is the other option? Is it machine learning is the other option? Uh, Now the question is like machine learning is not like one particular word, it's a science. It's just like a statistics, mathematics, or computer science. It's a big science. So we can't dig all the, each and every points of machine learning and try to understand which works. But as I am a statistics student, what I thought, instead of machine learning, let's do for a statistic learning. Or a statistical learning, which is a combination of statistics and machine learning, and we can make a simple way to actually implement those kind of methods in the probabilistic MME. So does it works or not, we don't know, but we have a concept, or we have actually a proof in a deterministic MME case. So long back, we published a paper on how to make a deterministic multimodal ensemble based on machine learning. And we found that machine learning actually works very well, especially it's actually captured the all spread or the uncertainty or the standard deviation of the observation. So we have this experience already. But there is a challenge. It's not a straightforward that you use the machine learning for deterministic and that exact machine learning can work for probabilistic, because the concepts are different. So that's what we started working on that. So we took up a method called extreme learning machine, or ELM, which is, I don't want to go much detail, but just to explain, this is a very generalized single feed-forward neural network. So we don't need a very deep, because we don't have much data set in the seasonal scale. The climate model gives us 30 or 40 years of hindcut. So we can't go for a very deep learning method. We can just go a very simple method. Again, in a simple method, there is a lots of layers and different method, whether you go for back propagation, this and that. But at the end of the story, it's all leads us our overestimation. So we need to go very simple method. That's what I go for, single feed forward method. And there is a maths behind that. It's not like just we are plugging this black box and just working on that. So the maths tell us it's kind of a linear method, but using a very nonlinear activation function. And this is like, again, more maths. I don't want to explain, just to keep that things. Now the question is like the limitation, like the traditional neural network is always go for a binary classification. For example, in image processing, whether it's a a photo of a cat or cat or dog, is very easy to use it. But in our case, in seasonal forecast, we have multi-class, like below normal, near normal, or you can make it like 5 categories. So it's not straightforward to use this kind of machine learning in that case. So we need to do a little bit of more sophisticated method. We found a very recent paper by Wong et al. That they are actually using this probabilistic output, and it's actually a difference between the traditional and the probabilistic output in the last layer of the machine learning. Like in ELM, traditionally they use a linear method, but here we have to use a sigmoid method. Again, lots of maths I don't want to explain, but there is not like a method available and we just plug it. So we have to work on that. But again, working on their method, we found there is a huge limitation, because they use a log function on the observed category, which is again leads at a very infinity kind of probability. And also those probabilities are mutually not mutually consistent. That means you get a probability, but if you take the sum, it's actually increase 100%. So we have to work on the method. So we kind of change inside the network. We change the different function. We found soft function is working, and we also, instead of getting 0 or 100% probability, we make some decimals so that the log function cannot lead us very infinity kind of probability. So doing all those nuts and bolts and changing the traditional system to our system, which can actually work for this this method. So we come up with the idea. So in simple way, like suppose you have a DCM prediction, how to do it, right? So take the output from the models, and then you do some pre-processing, min max or standardized anomaly kind of things. And then you do a kind of a one hot encoding, which is calculating this, whether this method, whether the category fall in below normal, above normal, near normal, and solve different kind of activation function. We use that ReLU and sigmoid, and then you actually calculate different kind of categories. So that's kind of one schematic diagram of all complicated system. Come to the results, like whether you are doing so much things, do you improve as results? Yes, of course we do, but we all know the seasonal forecast is not in a very simple way to get it. So this is the ROC curve for all India, and we get some more than 50% AOC, which is around 60. Kind of moderate skill, we can't expect that 90% or 80% AOC or 80 under curve, but it works. Now the question is whether it's work for the spatial scale. So we actually calculate this generalized ROC, which is a generalized of all different category, and more than 50%, that means your probability is discriminant the different incident, and we get kind of moderate scale. We don't say it's a best skill, but it's kind of moderate skill compared to non-parametric and parametric methods. We do need lots of work. We do need lots of hyperparameter of this machine learning. So that's the results. Now the question is how to do it. How can we can contribute this method to the community, especially if I talk about real-time forecast. So it's not so easy to calculate those, all different things because it's not available in the internet. We have to build up from the scratch. So we develop a tool called XCast, which is a combination of Xarray and forecast. It's available freely in Python. In Panda, there's lots of example we put it. Anyway, anybody can use it. Very simple to use. So this is the method this is the tool you can use for that. And I almost end in my talk that this remarks is like, there is a various method to make this probabilistic multimodal, but we use machine learning as a white box to understand each and every steps and understand why it's working or why it's not working. And that's the way we are actually working right now. And in future, we can actually add more methods. Just one, two take-home messages, especially using, I have seen like lots of students nowadays are very excited to use machine learning. So the thing is like most of the cases, like people are very excited to use different packages available in different software without understanding. But as we are dealing with the climate science where we have to explain each and every steps, so we really need an explainable AI. And basically the way I understand explainable AI is actually a statistics. So understanding machine learning in a statistic framework is much easier than understanding machine learning in an image processing framework, because that's not our background. So that's what like the take-home message, wherever we use machine learning, we should understand each and every steps. On that note, I said thank you very much, and really looking for comments and future collaboration. And I was a little fast because I know this is the last talk of this session. I don't want to go for more than the time I have given. Thank you very much. Thanks.
Thank you very much, Dr. Nachiketa, for your excellent talk on the new tools and data science, including AIML. Certainly, we have to adopt the dual technology. On the one hand, we have the numerical modeling. On the other hand, we have got artificial intelligence. Both have to go in a complementary manner, and that is the future technology for weather forecasting. Any questions and comments? So I find there is no questions and comments. So I thank you very much for your excellent talk, and I hope your work will help in future to develop this dual technology. Thank you very much.
Sure. Thank you very much.
Thank you very much, sir, for the nicely conducting the session. And this was the last session of technical session. So after that, there will be validity function, the concluding session. So we'll take a break for about 2 to 3 minutes. After that, we'll start the thing. कुछ हो गया कि
Namaste, Dr. Mohapatra. Namaste. Is my audio is audible? Patnaik, audio is working. Mitra here.
It is audible.
audible.
Working, yeah. Hello,
Okay,
Dr.
okay.
Mohapatra ji, Dr. Mitra ji. Namaste.
Namaskar.
Namaste, Krishnan. Namaste, Krishnan ji.
So we can start, Dr. Patnaik.
Yes, sir, we can start, sir. So very good evening, good morning, and good afternoon to all our viewers. So this is the final and concluding session of IWM-7. So we had very good 5-day session starting from 22nd March to 26th March today. So today we will be concluding the session, as it was a very wonderful experience for all of us, because virtual platform we arranged this such a big international event, spending our time morning and evening to accommodate many people from the different country. So it was a very, I feel it is very successful, and it was also a very good experience for all of us. So without wasting much time, now I will request our DGM sir, Dr. M. Mohapatra sir, PR of India with WMO, to kindly share his welcome address. Thank you.
Namaskar, good evening, good morning to all of you. At the outset, I extend a warm welcome to all the distinguished guests, panelists, delegates to this panel discussion and concluding session of International Workshop on Monsoon. We have with us Professor C.P. Chang, co-chair IWM-7, Professor Ajit Tyagi, co-chair IWM-7, Dr. Yukari from University of Tokyo, Dr. Krishnan, Director, Indian Institute of Tropical Meteorology, and Executive Director, Center for Climate Change Research, Dr. Ashish K. Mitra, Head of National Center for Meteorology Weather Forecasting, Dr. Rup Kumar, the scientist in International Monsoon Project Office in IITM Pune, Dr. Patnaik, and distinguished members of the organizing committee at the local level, national level, and international level. During past 5 days, we have come up with various discussions, deliberations on various processes of monsoons, the intraseasonal and interannual variabilities, the various large-scale processes governing the phenomena, their teleconnections, the impact of monsoon on various socioeconomic activities, the monitoring, predictions, and early warning with respect to monsoons, with special emphasis on numerical weather prediction modeling and use of data science in the present scenario. It has been really a very successful event in spite of the threat due to COVID-19, which has resulted in this virtual conferencing. We have been able to organize with a huge response and participation. The talks were of very high standard. At the same time, there was enough enthusiasm among the youngsters with their participation with oral presentations and short oral presentations and poster presentations. The workshop could bring out the current status of knowledge and also could identify the gap areas. It also paved the way for the further research and development, and hence the new policy and planning to be adopted, especially in view of the climate change and its impact on monsoon in present scenario and also the future scenarios. I hope we have quite a good number of recommendations from various sessions, thematic sessions. And the organizing committee will take care of that, and it will be documented, shared to not only the researchers, but also the policy makers and planners in the different countries dealing with the monsoon. I must thank all the chairpersons, co-chairpersons, rapporteurs for all the thematic sessions who participated for the success of this International Workshop Monsoon. My special thanks go to organizers, the young minds who are behind the hosting of this virtual conference. To further crystallize the outcome of this 5-day-long international workshop, we'll have a panel discussion with eminent scientists, as I mentioned a little earlier, and I hope their thoughts and inspirations will crystallize our ways and means to further improve the monsoon monitoring, monsoon research, and applications for societal benefit. So I once again welcome all the distinguished guests and panelists for this concluding session of IWM-7. Thank you.
Thank you very much, sir, for your nice introductory briefing about the concluding session. And we have a distinguished panelist here. We will like to hear from them. So it is very difficult for all of you to listen to all the sessions. So we will just give a brief report of the IWM-7, covering the entire proceedings from starting from 22nd, the initial day to the inauguration, and what are the activity, who are the invited speaker, all this. So we have prepared a small report of this thing. So I will suggest our team to kindly play that one.
IWM is organized by the World Weather Research Program, WWRP, Working Group on Tropical Meteorological Research, WGTMR, with co-sponsorship across WWRP and the World Climate Program, WCRP, CLIVAR and UX Monsoon Panel, and the WWRP and WCRP Sub-Seasonal to Seasonal S2S project. IWM-7 is organized by IMD, MOS, Government of India and WWRP Working Group on Tropical Meteorological Research, WGTMR, in cooperation with the WCRP CLIVAR UX Monsoons Panel, the International Monsoons Project Office, IMPO, hosted by ITM, Pune and Indian Meteorological Society, IMS, at New Delhi, India. History of IWMs. The first IWM in Indonesia 1997. Second in New Delhi, India 2000. Third in Hangzhou, China 2004. Fourth in Beijing, China, 2008. Fifth in Macau and Hong Kong, China, 2013. Sixth in Singapore, 2017, and IWM-7 in IMD, New Delhi, India, 2022 at virtual mode. The 7th series of WMO International Workshop on Monsoon was inaugurated on the World Meteorological Day, 23rd of March 2022. The Professor Chipe Chang highlighted the following scientific key message during inauguration of IWM-7. The most recent CMIP-6 projected 21st century land monsoon rainfall is 50% larger than CMIP-5, that is greater news. However, range of change also 50% larger, which is not so greater news. The most crucial challenge seems to prediction of internal variability, namely internal modes versus radiative forcings, to reduce uncertainties in projections. The Senior Advisor of Integrated Research and Action for Development, former Director of General Meteorology, India Meteorological Department, addressed during inauguration of IWM-7. Through the series of IWM in last 25 years, transfer of technology from researchers to forecasters has been brought out. Improvement in forecasts are really commendable. This is 7th series of IWMs being organized by the IMD, MOS, Government of India jointly with WMO, WWRP, WCRP. The Secretary of Ministry of Earth Sciences, MOES, Dr. M. Ravichandran addressed all the delegates of this 7th series of International Workshop on Monsoon, IWM-7, with following welcome message. We need to understand extreme weather under climate change, and for all aspects the Government of India launched monsoon missions. Whatever knowledge we gain in this IWM-7, we will need to integrate into the models for better services. The Directorate General of Meteorology, DGM, India Meteorological Department, IMD, Dr. M. Mohapatra addressed all the delegates of this 7th series of International Workshop on Monsoon, IWM-7, with following welcome message. This IWM-7 will bring capacity of the knowledge transfer from older generation to the younger generation, senior scientists to younger research scholars, and help us for better understanding about current research about monsoons in India and other parts of the world, and plan for future research and better progress towards it. The head of World Weather Research Program, WWRP, of World Meteorological Organization, WMO, Dr. Estelle de Koning addressed all the delegates of this 7th series of International Workshop on Monsoon, IWM-7, with the following welcome messages. The monsoon systems has huge impact on both economical and social, and accompany to the high-impact weather events, and also links to meteorology, climatology, hydrology, agriculture, and water resource management at all time scales. This information is much needed by the decision maker for early warning and early actions. To establish much needed dialogue between scientists and users on monsoon information, this workshop IWM-7 is most important one. The head of World Climate Research Program, WCRP, of World Meteorological Organization, WMO, Dr. Michael Sparrow addressed all the delegates of this 7th series of International Workshop on Monsoon, IWM-7, with the following welcome messages. This IWM-7 is a hub to bring global scientists together and continue to expand research on global monsoons in current and future projections and improvements of its predictability. We will continue to focus on research in sub-seasonal to seasonal, S2S, and climate future projects of global monsoons with more international and national partners. Sir Gilbert Walker Gold Medal is awarded for the scientific contributions in the fields of monsoon meteorology, including long-range forecasting of monsoon systems including tropical cyclones, and for overall contribution to the development of meteorology in India. The Sir Gilbert Walker Gold Medal consists of a citation, a medal, and award money of ₹1 lakhs. In recognition of outstanding contribution to monsoon meteorology, the Indian Meteorological Society awarded the Sir Gilbert Walker Gold Medal of the Indian Meteorological Society for the year 2019 to 2020 to Professor Dr. P. V. Joseph, on the WMO day of 23rd of March, 2022, to honor his lifetime contributions towards discovery of new phenomena, understanding of the atmospheric and other processes, and developing meteorological services for societal benefits. During the inauguration, the book containing all the abstracts of IWM-7 was released by the Secretary MOES, Dr. M. Ravichandran, DGM-IMD Dr. M. Mohapatra, and Coordinator, IWM-7 Dr. D. Patanayak. Warm welcome message from Professor Petritala's Secretary General, WMO during formal inauguration of IWM-7 on 23rd of March 2022.
Dear colleagues, ladies and gentlemen, on behalf of the World Meteorological Organization and on my own behalf, I would like to express WMO's appreciation to address the 7th International Workshop on Monsoons. I would like to thank the Government of India, especially the Ministry of Earth Sciences and the India Meteorological Department for hosting this online scientific event, which speaks of importance that India assigns to the vital climatic and environmental challenges that the international community faces today. I would like to congratulate the Indian government for taking several initiatives to tackle these climate and natural hazard issues. India is one of the few leaders in the implementation of the Paris Agreement on climate change. It has a national clean air program to combat air pollution because you are facing one of the most difficult air quality problems worldwide. You are a founding member of the International Solar Alliance and has been notable targets related to solar power energy. The Indian government has initiated several flagship projects on environment, Clean India, Clean Gangstam, Smart Cities Mission, to name a few. It is also in the forefront in weather and climate research. According to IPCC's sixth assessment report, the Northern Hemisphere land monsoon rainfall as a whole declined from 1950 to 1980 and rebounded after the 80s due to competing influences of internal climate variability and radiative forcing from rising greenhouse gas concentrations and aerosol forcing. Increases in monsoon precipitation due to warming from greenhouse gas emissions were counteracted by decreases in monsoon precipitation due to cooling from human-caused aerosol emissions over the 20th century. National Meteorological and Hydrological Services to fulfill its fundamental mission to provide increasingly better services not only to your respective national communities in protecting life and property and in support of sustainable development, but the global community as a whole. I can assure you that WMO will be at your side throughout this vital humanitarian endeavor. I wish to thank once again Dr. Mohapatra for his kind invitation to his entire team for the excellent coordination and arrangement in organizing this online monsoon workshop. To all participants of this workshop, your presence today speaks of your deep commitment to continue working together towards a safer world. May your collective endeavors in this workshop be fruitful. Thank you all for your kind attention.
Warm welcome message from Dr. Jitendra Singh, Honorable Minister of Earth Sciences, Government of India during formal inauguration of IWM-7.
Namaste. I welcome you all to this international workshop on monsoon being hosted by the India Meteorological Department, Ministry of Earth Sciences, Government of India. Ladies and gentlemen, you will be pleased to know that India is blessed with two monsoons. The southwest monsoon during the month from June to September and the northeast monsoon during October to December. India, under the leadership of Prime Minister Shri Narendra Modi, has launched an ambitious and a well-resourced research program on mission mode called the Monsoon Mission. Through this mission, ladies and gentlemen, India has augmented its capability of high-performance computing, the HPC, which is close to 10 petaflops now, and is able to generate forecasts of very high resolution with 3-kilometer resolution using mesoscale model, 12-kilometer using global forecast system model, and about 38-kilometer using ocean atmosphere coupled model. The monsoon mission has therefore and thus helped in the significant improvement of monsoon forecasts in all the time scales, right from short range to seasonal. The second phase of monsoon mission also focuses on sectoral applications and prediction of extreme weather. Substantial support is being provided by the Government of India, headed by Prime Minister Narendra Modi, under his guidance for monsoon research through the Monsoon Mission, which has successfully completed 2 phases and is about to embark on the 3rd phase from this year. The International Workshop on Monsoon is a major quadrennial symposia workshop series under the World Weather Research of the World Meteorological Organization, namely the WMO. The 7th workshop in the series is being organized at New Delhi, India, jointly by India Meteorological Department of Earth Sciences, Government of India, and the WWRP, that is the Working Group on Tropical Meteorological Research, WGTMR, in cooperation with Monsoons Panel of the World Climate Research Program WCRP and the International Monsoon Project Office IMPO, hosted by the Indian Institute of Tropical Meteorology IITM and Indian Meteorological Society the Iwms. To conclude, I wish the 7th edition of International Workshop on Monsoon a great success, and I'm sure we'll come out with some very valuable conclusions and inferences. Thank you once again, ladies and gentlemen, and namaste.
Various researchers from 18 different countries contributed their work in the IWM-7. There are total 185 abstracts in which 55 participants are from outside India and 20 additional registered participants are also attended the workshop. There are 185 papers were presented on 9 different themes, namely regional monsoons, S2S predictions, modeling monsoon processes, climate change and monsoons, high-impact monsoon weather, field experiments, and observational campaigns, monsoon information and prediction for societal benefit, and new technologies and tools. Total 38 invited talks in 9 sessions, total 72 oral talks in 12 parallel sessions, and 75 short oral talks in 3 sessions were conducted during this 5 days workshop IWM-7. A special issue of Quarterly Journal of Meteorology, Hydrology and Geophysics MOSM from this workshop IWM-7 will be published under the editorial team with Chief Guest Editor Professor Chih-Pei Chang. Thank you.
Thank you for our team to bring this a brief report highlighting the different activity from beginning first day to last day. So now with this, now I request our DGM sir, Mohapatra sir, to kindly start the panel discussion, and we have the panelists to take their views and comments on this. Thank you, sir.
Thank you, Dr. Patnaik, for this excellent review of the activities taken out during these last 5 days. Now we'll proceed for this panel discussion. The topic for the discussion is the future monsoon forecasting. And we have Professor C.P. Chang, Professor Ajit Tyagi, Dr. Yukari Takayevu, Dr. R. Krishnan, Dr. Ashish K. Mitra, Dr. Rup Kumar Kohli. So we will take about 40 minutes for discussions, and I will request each of our distinguished panelists to speak for about 3 to 4 minutes maximum. So we can go for 3 minutes on the first round, then we can come up again if required to the second round with 1 minute or so for a concluding statement. So at first, I request Professor C.P. Chang to keep his views on future of monsoon forecasting. Your audio is muted.
Audio, your audio.
Thank you very much. First, I must congratulate Dr. Mohapatra, Director General of IMD, and the super outstanding achievement of sponsoring and hosting this workshop. Everything is beyond my wild dream on the success, and also he has a very strong team, including Dr. Patnaik and other IMD colleagues, and also we need to thank very much the leaders and the staff of IMPO and others, too many to mention. For IWM, this started was kind of like an accident. Actually, when I think about it, it traced back to I'll have to say 1995. There was a meeting in Beijing, a small meeting in Beijing, and then we talk about possibly have this, and the person, the head of a working group of tropical meteorological research was Dr. Greg Holland of Australia. Weather Bureau or Meteorological Bureau. But anyhow, in order to make this workshop different from all the other normal regular workshops, there are tons of monsoon meetings. And in the very beginning, actually, when I got involved, also by accident in Bali, I had a talk with Gray Holland, and we think it would be better to have the workshop as organized so that it's not like everybody just submit a paper and all come here and give a talk, but we should organize in such a way that there's a structure so can cover various part of the important topic as monsoon research, and as part of WMO activity should be closely related to forecasts. So that would different from the other academic type of workshop. And finally, we're seeing that this is gradually being sort of accomplished as IWM proceeds. I remember back in IWM-2 in Delhi, there was a lot of training, but the science part was separate in the first week. And then in 2015, we went back to Delhi. That was the monsoon heavy rainfall workshop. And it was great that a lot of both academics and forecasters participated. And finally, here, I think in the future, the monsoon research needs to involve both communities. It can't just be those people who can do great research and produce great science and write great papers, but we must also have forecasters, and they would come in and bring up their problems and their interests and their challenges. And it's obvious we have a lot of challenges in front of us, and this is a very good sort of, it's not starting point, but it's a very good intermediate point of IWM-7, and with the heavy involvement of a weather service that is the IMD. So we should continue in this path. We should bring both communities and work together. And I hope that IMD and IMPO will continue to play leadership roles in the future. Thank you.
Thank you very much, Professor Chang. You have correctly brought out the historical evolution and the objective of this workshop and the way forward. May I now request Professor Ajit Tyagi, the co-chair of IWM-7.
Thank you, Dr. Mohapatra, Professor Chang, and esteemed co-panelists. It's a great honor to be part of this esteemed panel. And at the outset, let me also convey thanks to the India Met Department for having successfully organized this workshop despite various challenges posed by the pandemic. Now, as far as the monsoon research in the recent decades is concerned, it has positively led to the significant improvement in the weather forecast. But still there are gaps. Particularly, I like to focus three areas. First is that localized high impact weather, heavy rainfall events. Second is subseasonal to seasonal variability of active break cycle and leading to droughts in some cases. And third, at the climate scale, the projection at the sub-regional to the local scale for effective adaptation strategies. Another thing which is being brought out again is that this provides a platform from scientists to the forecasters to the users. Somehow, in the coming years, most important thing is to the delivery of the forecast to the users and user-specific applications. So this is one area which the value addition needs to be brought in, both by handholding of the monsoon meteorologist and the user sector. Now, just 2 days back, UN Secretary General has brought out the importance of and launched a 5-year project of delivery of the weather forecast and early warnings to the last man in the globe. This 5-year project will be led by the World Meteorological Organization, and the most affected areas for this is the monsoon region. 1/3 of the population in the least developing and developing countries lie in the monsoon region, and 60% of these are from the African countries. One of the weak areas of this monsoon workshop had been that we didn't have adequate representation from African countries. So need to develop a monsoon meteorology community in the African countries. And another is also very active participation of the user community in our future workshops. Thank you.
Thank you very much, Professor Tyagi, for your excellent summary of the achievement of this workshop and your views for the future work. May I now request Dr. Yukari Takayabu for his valuable comments.
Namaste.
Yeah, yes, please, madam.
Okay. Thank you very much. It was my honor to attend this workshop. And first, I would like to congratulate Dr. Mohapatra and thank Dr. Patanaik and all the IWM-7 organizers for a very successful 5-day monsoon workshop. I also would like to thank all the presenters for wonderful lectures. I found this workshop consists of monsoon studies from a very wide range of views. I learned a lot from historical views to the novel methodologies to understand monsoon variabilities in various spatial and temporal scales. Monsoon weather and climate are very complex systems, difficult to understand and to forecast. But I find scientists are successfully proceeding to untangle the complex monsoon systems. I really enjoyed this workshop, and I hope these further efforts, collaborations, will help to achieve for the sustainable development goals for our society. Thank you very much again.
Thank you very much, Dr. Yukari, for your views. May I now request Dr. R. Krishnan, Director in Institute of Tropical Meteorology, also the Executive Director for Climate Change Research, for the views.
Yeah, thank you, Dr. Mohapatra ji, chair of this session, and DGM-IMD. And I also want to thank all the panelists today. Professor C.P. Chang, co-chair of IWM-7. Professor Ajit Tyagi is also a co-chair of IWM-7. Professor Yukari Takayabu, co-panelist, Dr. Ashish Mitra, Dr. Rupakumar Kulli, and Dr. Patnaik, who has done a great job. Many thanks to all of you. It's a great honor for me to participate in this as a panelist. And let me congratulate Dr. Mohapatra, Dr. Patnaik, and the entire team of all the organizers. They have done an extraordinary job. And this has been a very, very successful event. It is a grand success. And first of all the topics were very well structured, the wide range of topics. It covered all the monsoon regions of the world, the talks especially, and excellent high quality presentations. They were really outstanding. And many young early career scientists also presented. And this made it very, very impressive. And I also want to particularly thank IMPO and IATM, along with IMD, who played a key role and provided leadership in organizing this workshop. And with this, the future, regarding the future of monsoon forecasting, so with the climate change, these extreme events are becoming more frequent. And one of the challenges in the monsoon region is the heavy precipitation during the monsoon season. They are coupled to the circulation. And there are mesoscale convective systems which organize and which can produce very heavy rainfall, and which came out in many of these present talks today. Also, land surface processes, air-sea interactions, they are on different time scales. And internal variability, which is affecting these extreme precipitation. So on the one hand, we need the basic research to understand the underlying processes to be able to improve the models, representation of these processes in the models. And so understanding of the process and the representation in model is very important. And the second thing is prediction. So we definitely need high resolution models, which we are already going. And also data assimilation is going to be a key because especially with increasing moisture in the atmosphere, water vapor is going to be a key parameter. And in addition to the winds, vertical structure of the winds. And now with AI, ML and new techniques, probably with more data becoming available, hopefully we may be able to improve some of the key physical processes in the models. And of course, this region, the monsoon, the Himalayas is a very important region where today morning also there's showed very strong diurnal variability in the precipitation as well as links to subseasonal variations like the QBO and BSISO. So internal variability is a very important source of uncertainty besides various drivers like greenhouse gases and aerosols and land use changes. So these are grand challenging problems which we need to address in the future. And I am sure the IMPO will be a great platform because it brings in together the expertise from WWRP and WCRP and all the regional monsoons. And I'm really looking forward to the successful predictions on the monsoon in the future. Thank you very much for this opportunity.
Thank you very much, Dr. Krishnan, for bringing out the issues at hand and the suggestions for the future work to improve the monsoon forecasting. You have correctly brought out the need for further research and improvement in forecasting the internal dynamics and hence the internal variability of monsoon. You have correctly brought out the role of land use changes and the aerosols, which are the new emerging areas and likely to impact and hence taken into consideration in view of the ongoing climate changes. The role of resolutions and physics and physical processes, as well as the combination of data science, also you have brought out that could be the future research for improvement of monsoon forecasting. So thank you very much. Now I request Dr. Ashish Mitra, Head of National Center for Medium Range Weather Forecasting. And this center is basically dealing with the seamless forecasting from nowcasting to extended and seasonal forecasting of monsoon. Dr. Mitra, may give your views, please.
Thank you, Dr. Mohapatra. First, let me congratulate IMD, Dr. Mohapatra, and the whole team for this very successful workshop, and the chairs and co-chairs of IWM-7. It's a fantastic workshop last 5 days, and I didn't feel that it was online and we lost something because it has generated a wealth of presentations which are available in YouTube, and recordings are available. So I think the younger students and even will come back and refer to all the presentations and talks again and again. So it's a fantastic wealth of knowledge which will be available over the internet. So congratulations for that. And thank you, the co-chairs, for giving me this opportunity. So what I feel for advancing this monsoon research, when we look back from this workshop and recent publications, these reanalysis data sets have advanced our knowledge, both the satellite data and the reanalysis. So reanalysis of the atmosphere, ocean, land surface. So tremendous understanding of the monsoon at different scale has happened. So that is one work which has to continue with very high resolution reanalysis. So like our Ministry of Earth Sciences has produced under Monsoon Mission regional reanalysis for Indian region, 40 years and 12 kilometer, very high resolution. And there are 18,000 users already using that to churn out new knowledge. So that kind of ocean, atmosphere, and land surface reanalysis data has to be produced, which will be very valuable for understanding the monsoon. And because of the HPC and satellite data and other radar data, the model resolution has improved. So there is a lot of improvement in the monsoon modeling, but still for the world community, the monsoon modeling is a change. So it's a good thing for South Asian region and our people that whole international community is attracted, and like a benchmark, any modelers will come back and see how good or bad is the monsoon, what are the biases, whether the teleconnections are good or not. So that India government also put a lot of resources in Monsoon Mission. So I think the monsoon research is very encouraging because it's a challenge for the scientific community. So all the scientists are attracted to work on this. And I think Government of India will continue to support research in this monsoon related topics. And the last item I would like to focus, which Dr. Krishnan has also told, the initializing the model. See, we may develop high resolution model, but the data gaps, particularly some regions of the globe and the difficult mountain terrains, we don't have any data. So the models are improving. So we are not able to validate the model because model validation and diagnostics are important part of model development. So how to, we may need WMO's help and some other cooperation to put extra observation or through satellites, the difficult terrain like mountain, deserts, and the cryosphere, collecting this data and validating the model. And one research particularly I remember, our great monsoon scientist, Professor T.N. Krishnamurthy. So he used to do a work on scale interaction. So the scale interaction diagnostics, it brings out the deficiencies in the model. So that kind of diagnostic has to be continued. See, because the models are there, but the multi-scale complex coupled system of the monsoon, we are not able to properly diagnose that what to do. If we do make some changes in the convective scale, the benefit we are getting or not. So diagnostics remains an important point which has to continue. Thank you.
Thank you very much, Dr. Mitra. So you have correctly identified the gaps in the regional monsoons, especially the role of the data sparse oceans and hills like the Himalayas, where we have to augment the observational network and we have to understand the physical processes occurring in these regions. They also highlighted the continuity required for reanalysis studies with higher resolutions and better understanding of the knowledge. The role of data assimilations, yes, certainly it has to improve. It is a continuous process along with the resolutions and physical processes. The scale interaction is another area where we have to improve our diagnosis and to have, for example, a seamless forecasting and better understanding. The most important point, whatever you have brought out, that is the collaboration among the various R&D institutions. That is also a key to the success so far under the umbrella of World Meteorological Organizations and various other bodies. All the countries under monsoon have worked together and they have brought out the achievements, whatever we see today. But still there is scope to further collaborate and hence to improve our observational systems, monitoring systems, numerical modeling, and forecasting and early warning. There has been a number of regional mechanisms in terms of the forecast development program or forecast demonstration projects in terms of associated heavy rainfalls or associated impacts or in development of the modelings. But all these regionally oriented projects need to be collaborated with each other so that there could be a better coordination mechanism and understanding in a global scale. And certainly, the exchange of knowledge from one experiment to the other will help to improve our understanding. So thank you very much for your very judicious comments and suggestions for future work in monsoon forecasting. I would now request Dr. Rupkumar Kohli. I don't know whether Dr. Patnaik, whether Dr. Rupkumar.
There was a message that he's going somewhere.
Right.
Whether possible or not, not sure.
Fine,
So
fine. So with all these valuable comments and suggestions for the future work on monsoon forecasting, I open the floor for comments from our distinguished delegates and participants. So anyone wants to have any comments and suggestions or any questions to the panels? Any questions to the panelists? It is open now. Are any comments or suggestions with respect to the future of monsoon forecasting? So if there is no question, so I will have one question to my co-panelists. So there has been a significant improvement with respect to monsoon monitoring, understanding, predictions, and the forecast in different scales, from nowcasting to seasonal forecasting. But still, there are certain uncertainties with respect to the various types of severe weather associated with the monsoon, especially in the regions where we have a varied socioeconomic behavior. And also, there are challenges because of the data sparse in the region. So my question is, how can we communicate the forecast and early warning in a better manner in spite of all these constraints? And how can we maximize the utilization of the knowledge gained so far? And what will be the future with the supposed improvement in monsoon forecasting? It is open, anyone can respond. What could be, in short, what could be the future of communicating the forecast and its uncertainty associated with monsoon? Yeah, Professor Chang. You're muted.
I have been thinking about the problem of communications to the public of the forecast and other meteorological information, and I think the news media is very important in this. It used to be like TV stations and newspapers, and nowadays you have all this website. But one idea I had was to have some sort of training courses for the journalists. For instance, IMD could give a 2-week or not every day, 8 hours a day, but some sort of short training program. And this way, you can make the journalists to understand more about what's behind the forecast, what are the problems, the confidence level, those sort of issues, and also why sometimes forecasts are wrong, and what sort of the correct questions they should ask IMD, so they would not ask some sort of questions that you don't know how to answer them because they don't understand the problem. So some sort of training or education program to make the journalists more knowledgeable about the forecasting, the whole procedure, the problems, what is a reasonable one, different difficulties, so forth. So that's my idea. And then you can also give certificate to those journalists who have received your training, so they can claim to be an expert, they would get better salaries from their employers because they are certified journalists in the area of climate and weather.
Thank you, Professor Chang. Thank you, sir, Professor Tyagi.
Well, I'll add to what Professor Chang has said. No doubt the National Met and Hydrological Services have to play an important role, but these needs to be complemented. No Met service can reach last man in the community, particularly in the remote areas. So what we really require is a participation of various science NGOs and meteorological societies. Like in India, we have an India Meteorological Society, and also which can create a public awareness, outreach, and through the citizen science can provide a two-way communication to the people in the field, students, including the students, where they can communicate your forecast to their families and also provide feedback about the happening of weather at that region. So this is, I think, the area which badly required, and it is being recognized worldwide that improved forecasts did not and does not lead to the improvement on the ground always. Okay, but the tech-savvy people will make use of these forecasts, but a common man may not be benefited, and particularly the last man in the community, the poor people who are get affected. So we need an outreach system, and which government agencies alone cannot do it. So we need to make use of NGOs, science NGOs, the professional med societies to do this task. And it is very important task, as good as improvement in the forecast. Thank you.
Thank you, Professor Tyagi. Anyone else wants to respond? Otherwise, yeah, Dr. Krishnan.
Thank you, Dr. Mohapatra ji. Yeah, this is actually raised a very tough question. It's not a, especially the rate at which these heavy precipitation events are happening. They're happening at a very, very fast rate. And because last year we had last monsoon, 600 millimeters of rain in Mahabaleshwar. So that's, or in Chennai, we had something like a 20 centimeters of rain, which was hardly, there was no clue. And these are very big surprises. And these type of events are becoming more common, and in future they are projected to increase. And I think first of all, I think models are having challenges getting those type of events. Tropical cyclones, we have definitely improved. By the time they form in the ocean, they grow and they make a landfall. But these heavy precipitation events which lead to flooding, they are the big surprises. And so first of all, ability of the models to do those events, that we have to understand, and how to downscale at local level and how to communicate. So there are different steps. So it is I think it is something that needs a lot of thinking and planning, and it's a lot of strategy is also needed. I really don't have an answer, but it's a very tough question that you have raised. Yeah.
Okay.
Thank
Dr.
you.
Mitra.
Yeah, I wanted to make just one point, that we have been communicating the forecast, but with this ensemble forecasting system, very high resolution global and regional models, we are getting a lot of information on uncertainty. So the end user, if they are educated, or even the uneducated end user, they are very intelligent and they can make use of these uncertainties. So we should give a lot of importance along with the forecast. How much is the uncertainty? Then leave it to the planners, administrator, end user to make use of it. So that is like developed USA, Europe, etc., Japan, they are making use of it. But in our South Asia region, we are not making enough use of uncertainty and giving forecast in terms of probabilistic. We think that as a meteorologist, it's not good to convey the uncertainty, but the end user needs it, and they will make very nice use of it in business, in applications, or disaster management. Thank you.
Yeah, Professor Mohanty.
Thank you very much.
You're muted.
Yeah, I agree with you, Professor Tyagi, and I feel that actually the end users should have awareness and they should have the demand. And for that, they have to know the limitations and its usefulness. So for this purpose, I feel two things. One, we should intimately involve the state governments and children, the school children, because they are the better way up, because we don't have any course in school or anywhere about the climate, weather science. And it is such a citizen science of common people. So I think either through society or through the IMD, I think we should take this knowledge to the end users, to the school children, and to encourage them to know this thing and communicate to the parents or to the villagers and so on, because maximum is the farmers and they need this useful information. Thank you.
Thank you. We have a question from Dr. Brian.
Yeah,
In the chat box. How much research is carried out in South Asia into how people respond to warnings and why? We know quite a lot about this for Europe and North America, but different cultures have different responses, and what works in Europe may have quite different results in India or Bangladesh. Whether anyone will respond from the panel or from outside? Otherwise, I will respond to being the DGM-IMD. So this is become, this is, you can say, a part of our duty to have a survey about the response of the various kinds of users. And India Meteorological Department conducts the survey along with other sister organizations in Ministry of Earth Sciences. The first survey we conducted in 2010, then we conducted in 2015, then we conducted in 2020. And this survey is an independent survey to evaluate the response of the public, various stakeholders towards the forecast and warnings issued by India Meteorological Department. We have initially taken off certain cases like monsoonal heavy rainfalls and tropical cyclones. Afterwards, we took the applications like agro-meteorological advisory services issued to the farmers, fisherman warning issued to the fishermen. So like that, so gradually if I compare 2010, 2015 and 2020, we find that the response of the stakeholders and public is increasing over the years. They are appreciating the forecast informations being provided. And also we've got certain comments and suggestions from them. These reports are published, and survey was conducted by an independent body based on samples, National Center for Applied Economic Research. So this is one kind of documented research what we have. In addition to that, what we do actually, we go for some kind of survey or feedback mechanism, online feedback mechanism, which is available in IMD website. And there we analyze from time to time for various stakeholders. Recently, we took the farmers, one category, and we try to evaluate what is their response with respect to the forecast being provided every week as a crop weather combined informations. But there also we evaluated the mode of communications, whether it's audio or visual, textual, and also the means of communications, whether it should be radio or TV or should be the WhatsApp group. So it is really helping. And what we find that this evaluation process with the various stakeholders has to continue. and that helps us to fine tune our approaches. In addition to that, also we go for some kind of physical interaction with the various stakeholders, and there also we take the feedbacks. But people appreciate the uncertainty given in our bulletin in terms of likely, very likely, most likely in the textual form about the occurrence. To some extent, they appreciate the uncertainty given in the tropical cyclone track forecast, tropical cyclone wind forecast. But when we come towards heavy rainfall intensity, it is so drastically changing during the season itself or during the day itself, the forecast has a larger uncertainty. And with the growing demand with respect to the urban flood modeling, with respect to the riverine flood modeling, with respect to the flash floods, especially in the hilly regions of northern India and western coast and east coast, and its severe impact in terms of the landslides, mudslips, etc. What people expect that there should be some kind of objective mechanism to quantify the uncertainty, and that should be communicated along with the forecast. So we are trying to do that, considering both the scales like impact, expected impact, and likelihood of occurrence according to the color codes. And for last 3 years, we're issuing some kind of impact-based forecast and trying to communicate uncertainty in terms of the probability assigned to the expected event along with the color codes. But I feel still we have to go a long way to improve further the communication and quantification of the uncertainty. There is another question, I think, from Dr. Nachiketa. This question is that I have another comments or questions. As we know, we have coupled GCM for monsoon forecast, and we do bias correction focusing on the mean bias. However, we ignore the trend part. GCM have their own climate trend, which is not same as observed trend. So how to incorporate this mismatch of trend while calibrating the GCM using statistical bias correction? Dr. Mitra?
Yeah, actually, I chatted with him. So this trend definitely the models have when we run the model for longer times, like years and decades. But so he is inquiring about subseasonal to seasonal scale. So I have not seen much in the literature trends developing within a seasonal forecast, let's say 3 to 4 months, because monsoon forecast, we cannot go beyond 3 to 4 months. So if it is there, I am sure the statistical techniques, etc., can be used, because removing a trend, it's like a systematic error, should be possible. So I am not aware in the literature if somebody has documented the trend in the subseasonal to seasonal scale. But definitely biases and making a multi-model, now this AI/ML, this is helping. So maybe Nachiketa can clarify if it is documented in some literature. So I would like to see that within a season, 3 to 4 months of forecast, the trends develop, particularly for monsoon in a model. Thank you.
Sir, actually, yes, there is very few literature right now on this scale, but these are very emerging problems, especially the monsoon forecast, temperature forecast, because what happened, because we need a lot of data for statistical bias correction, but on that scale, we have like, let's say 40, 50 years of data. And especially on the ENSO prediction, monsoon prediction, each climate model, especially couple model, have their own trend, which is not same as the observed trend, especially in different category of rainfall, like extreme rainfall, mid rainfall. So people are actually started working on that, but very few people. I was just thinking if the panel have any idea on that. Otherwise, we can discuss later in different format. Thank you.
Thank you, Dr. Krishnan, please.
Yeah. Thank you, Dr. Mohapatra. I think what Dr. Nachiketa was asking was where the trends in the biases, right? How the biases are evolving. Is that what you mean on the subseasonal time scale?
Is actually both a fold, like, bias, obviously, and also the real trend, like, that inherent climate trend within the, because all this not running for 100 years, but it's run for at least 30, 40 years as a reforecast.
Yeah. So, but I think there is some work from NCMRWF. In fact, they were showing the biases developed within the first 6 hours or something, the precipitation forecast, which propagate into medium and extended range time scale. And I heard this some time ago in one of the NCMRWF presentations. And they grow very quickly. That is the problem.
Yeah, Nachiketa, you are telling hindcast 30, 40 years, but the length of each forecast is only few months. There may be data set for 30, 40 years. So we have to see that how fast the trend is coming. So I have not seen anything in the literature. So we'll discuss it offline. As far as I know, within a season, 3 to 4 months, I have not seen anything the trend, but there must be slight trend, yeah, which can be corrected. Thank you.
So thank you very much. Thank you very much. We are coming closer to allotted time. And I will just summarize now what we could get the inputs towards the future of monsoon forecasting. So based on all these discussions, deliberations, and the judicious opinion by all the panelists, what we find that the future of monsoon forecasting is quite bright, and we can hope for better forecast and better service to the community. We can also hope for minimizing further the loss of lives and properties from the vagaries of monsoon. The way forward for the purpose, what I find that we have to go for the augmented observational network, especially addressing the data sparse region, the sea areas, and the hills. The second step would be the further augmentation in our process studies so that we address all the physical processes to understand the monsoon, all time scales and the space scales. The next step will be the development of the better numerical modeling system, which is an ongoing process with the higher and higher resolutions, data assimilations, incorporation of various physical processes, development of the various types of forecast products with post-processing, and hence its conversion into a better public weather service with quantification of uncertainty and explicit application of the forecast values. While doing so, parallelly, there will be a knowledge base developed from the data science, especially the artificial intelligence and machine learning. Both will be complementing as a dual engine, and hence we will have a better pre-processing, post-processing, development of the products, decision making, and communication to the various stakeholders. There will be need for a seamless forecasting, understanding of the scale error, properties, diagnosis. We will also need a better collaborations and coordination among the various countries, the various research labs, operational centers, so that we can have a direct transfer of knowledge from research to operations in all scales. We should have a direct mechanism for communicating among the regional monsoon centers so that really the regional monsoon centers act coherently with the global monsoon centers. And by that way, the centers like IMPO can do a major role. Further, if I look at, say, for next 10 years, as we see now, the forecast generated by the numerical models and the various statistical tools, including data, AIML, etc., are aiming at converting the analog process to an automated process. So thereby, the role of forecasting, the nature of forecasting will gradually be converted from an analog manner, from a human-intensive mechanism to a machine-intensive mechanism with complete automations. And at that time, perhaps the role of forecasters will change, and forecasters will be playing a role of a basic interpreter, analyzer, enabler for the various stakeholders by providing a direct model output with various kinds of statistical applications. Perhaps that is the future for the monsoon forecasting, and all of us have to work towards that direction. And I hope with this international collaboration on monsoon, with this continued effort through these international workshops like IWM-7, we will be able to achieve this goal. So thank you very much, all my distinguished panelists, for their active contribution, and all the distinguished delegates for their suggestions and comments. Thank you.
Thank you, Dr. Mohapatra sir, for chairing this wonderful session. It was a really challenging discussion, the issue of monsoon forecasting, future, and also there are very good deliberation on the issue. And yes, definitely, as you have summarized, yes, in future it is good that monsoon forecasting will improve in future with the IMPO, IITM, and international community taking many activities and research on this area. Thank you. With this, actually, we conclude the panel discussion part. And as you know, I'll come to the next item. As you know, India Mass Society also in cooperation with the other thing involved in this IMW. So this is International Workshop on Monsoon. And you know that this is the society also bringing out the bulletin, that is India Mass Society bulletin, that is called Biomandal, once in 6 months regularly. And the Professor S.K. Das, he has taken over this charge of the chief executive editor of this journal for last 4 or 5 years, and now it is very regular, and we are bringing out. So on this occasion, we would like to release 1 volume of this Biomandal, that is volume number 47, number 2. So now I request Professor Das sir, our president, sir, IMS president, Dr. M. Mohapatra sir, and I am having copy to release this book on this occasion. Yeah, so this is the main hard work of Dr. S.K. Das sir and our also executive editor, Dr. Kamaljit madam. Thank you, sir. You'd like to say?
For the knowledge of our international community, I just want to mention that Biomandal is the official publication of Indian Meteorological Society. Biomandal is a Hindi word. Its meaning is atmosphere. So therefore, it publishes all types of literature dealing with the atmospheric sciences, especially the weather and climate sciences. I should appreciate and express my gratitude to Professor S.K. Das, who is the editor of this Biomandal. The scope of Biomandal has been ever increasing. Biomandal, all the copies you can find out online, and we are trying now to make it completely online journals in near future. It is helping the young minds to publish their literature, and also it is helping for further R&D. I am sure the Indian Meteorological Society will continue to improve this Biomandal to the international standard. Thank you. Do you want to speak, Professor Das? Just 1 minute.
I thank you so much. I would also like to inform the international community, those who might not know about Biomandal, that still 2 volumes are available on the website of IMS Society, www.imssociety.org, under publication head. First issue of every year is available by 30th June without fail. The early version or the online version. And the second issue is available by end of the year, that is December. And this particular volume is the latest one, that is 47/2, 47 volume, second issue of the year. And it was already available. It is already available on the website because this is for the period July to December. But the printing takes some time, the hard copy, and that is why we're releasing today. Also, we're waiting for some good occasion so that it will be known to the international community. I invite all the distinguished scientists to submit their papers or review articles. This has regular sections like 2 or 3 or 4 review articles, then some original scientific papers, and then some reports about the extreme weathers in India for the winter phase and the summer phase, and also the reports from the events of each chapter. There are 32 chapters of IMS over India, and then we welcome the new members. So I request all the scientists to contribute because it can be published within 5-6 months without fail. And I thank my committee, editorial committee, consisting of executive director, editor Kamaljit, Dr. Kamaljit Ray, and managing editor, our secretary of IMS, Dr. Patnaik, dear Patnaik, and the reviewers for their timely response, and overall to the IMS National Council, and specifically the authors and the scientists. I request to submit review articles. With these words, I thank everybody and expect that we'll get some good articles from the international community. There are some papers coming from Indonesia, Bangladesh, Thailand, countries nearby India. We are getting regularly for Russia also, and I request others to please contribute and help the this particular. This is a very, very old. For several years, it has been published. Thank you very much.
Thank you, sir. So, yeah. So last item, sir, should I go for vote of thanks? Yeah.
Yes, please.
Yeah. So it is really honor for me to give formal vote of thanks, and it is really plenty of people to I must thank, because organizing such an event is not very easy. So both at international level, at national level, and also the other department. So let me first thank our honorable minister, Dr. Jitendra Singh ji, for kindly spending valuable time, and also the recording message. He could not attend due to the parliament session, but he has sent the video message, and very encouraging word. What are the government of India is doing for the monsoon research and monsoon mission? So we are thankful to him. Then our Secretary General of WMO, Professor Patrice Talas, he has also given a very good overview of the monsoon and what the WMO is doing for the severe weather forecasting, and also he has encouraged how the India government is hosting this one, and also the monsoon research related thing. So we are thankful to him, and also their secretarial staff of the WMO, that Gina Kahana and Toeng Peng. So both of them, I was in constant touch with them for all the thing that we could do with the WMO. Then our secretary MOS, Dr. M. Ravichandran sir, and the entire MOS, they have supported from the beginning, and otherwise it would not be possible to organize such an event. So we are getting continuous guidance and support. We are having some NOC meeting time to time. So we are thankful to all the MOS support. Then I'm coming to the our DGM sir and PR of India, Dr. M. Mohapatra sir. Without his guidance and support, it not been possible to organize such an event in IMD, because yes, it was very difficult for IMD also to organize such a virtual platform in a bigger scale. And yes, it was his support and guidance that help us to plan and also execute the plan and successfully for completion of the plan. So everything went well. So it was his guidance. So thank you. And also finally for allowing a special issue of Mosam to be as a proceedings of this IWM-7. So that special issue that will be also give visibility to the international committee and the monsoon research. So thank you very much, sir. Then our co-chair of international committee, Professor C.P. Chang, Dr. Ajit Tyagi, in the scientific program committee, like Dr. Ikari, Dr. Joe, and Dr. Rupakumar, we used to have all interaction for planning of this session from last 3-4 months. How to do, what are the type of session, how to get the time lag, etc. There are many issues, how many invited, oral, short oral, but we have not rejected any papers. So we have accommodated either in short oral poster or poster. And there are 38 invited talks. It was very good, covering entire monsoon of entire globe. So we must thank all the scientific committee and also all the contributors and the chairs for contributing such a very valuable document. As Dr. Mitra sir was telling, that this will be in future also very helpful. Then WWRP head and WCRP head, Dr. Estelle and Dr. Michael, they also came and they gave their comments and how the monsoon research should improve, and they are working with IMPO and other things. So we also thank WRP and WCRP. Then coming to our IITM colleagues, they have organized successfully this IMPO, this training workshop particularly, that was event organized in November. Otherwise, in physical mode, it is just adjacent to our IWM-7 workshop, it would have been arranged. But anyway, that was arranged in November in IMPO. Dr. Rupakumar, Dr. Krishnan, and the IMPO team from IITM, they have worked hard, and we are also part of that. That was also very successfully arranged. So I must thank all of them. Then our local team in IMD, our international division, Dr. Giri, our MHA, MEA, and our this IT team, our new colleagues, they work on this thing, how to work for a physical, means not in the absence of physical thing, how we can manage this one. So our technical team, yes, I can name few: Dr. Arulalan, Dr. Bushe, Dr. Das, Dr. Giri, Dr. Soni, and administration type, and many things. So I might have missed some names, so I cannot take all the names. So I'm each and everyone, I am very much thankful to you for all the support that we have got in arranging this such a wonderful session and 5 days. And I must thank everybody, international community, and also the national committee, those who have contributed for successful arranging of the event. Thank you. So before we close, I'll just request all of you to kindly switch on the camera so that we can at least take a snapshot of the participants in the concluding session. Yeah, multiple people can take the snap also. Yeah, please.
Can collect all the snaps and choose the best.
Yeah, yes. Yeah. Yeah. So I have taken 2. So with this, I think, thank you very much. Nice to see you sometime in physical mode, maybe in near future or after 1 or 2 years. We must like to have some physical discussion, physical training that also we needed.
Thank you.
Thank you very much, sir. Thank you. Good night.
Thank you. Bye-bye.
Thank you. Bye-bye.
Everyone, and bye.
Thank you.
Thank you, Dr. Hi, sir. अरे अच्छा हो गया. ये हो गया यार, है ना. अच्छा, 1 सेकंड में जस्ट